Evaluate by converting to exponential form. So we start out by equaling the log form to x. And we're going to apply the power law for logs. So whenever we have a numerical coefficient in front of the log, it can be moved into the log, becoming an exponent. So this can be rewritten as log 10 of 0.001 to the power of 4 equals to x. We rewrite this now in exponential form. So it's going to be 10. This is the base of the log to the power of x equals the argument of the log, 0.001 to the power of 4. We need to rewrite this in the same base. So the base here is going to be 10. So 10 to the power of x equals. So 0.001 can be written with a base of 10 as 10 to the power of negative 3 and then to the power of 4. We're going to apply the power of a power law, which means we're going to multiply those exponents, which means we get 10 to the power of negative 12. Once we have the same base on both sides of the equal sign, we can drop the bases and continue with just the exponents. So we have x equals to negative 12. And that's our answer. In B, we have 6 to the power of log 6 of 36. So what you can do here is that you can just pull out the exponent here, because this is where we have the log. We want to evaluate this log by converting it to exponential form. Once we have evaluated this log, we can plug that answer back as an exponent to this 6 and then evaluate 6 to that exponent. Okay, so I'm going to just pull out that exponent. So I have log 6 of 36. We will equal that to x. We rewrite this in exponential form. So it's going to be 6 to the power of x equals 36. We rewrite this in the same base, so base 6. On the right hand side, 36 can be written as 6 squared. Once the bases are the same, we drop the bases and we only focus on the exponent, so x equals to 2. So we know now that this exponent here equals to 2. So we can now plug that back into the power we had. We had 6 to the power, or we have 6 to the power 2 now, which equals to 36. And in C, we have 3 log with a base of 1 over 10 of 10 minus 2 times log with a base of 1 over 10 of 1 over 100. So here we can start by applying the power law for logs, which means we're going to take these numerical coefficients in front of the logs and we're going to move them into the log, and they will become the exponent of the arguments. So if we do that, we're going to get log with a base of 1 over 10 of 10 cubed minus log with a base of 1 over 10 of 1 over 100 squared. Now we can now evaluate these arguments. So 10 cubed is 1,000, and then 1 over 100 squared. 1 over 100 squared is going to be 1 over 10,000. So we're going to get log with a base of 1 over 10 of 1000 minus log of, with a base of 1 over 10 of 1 over 10,000. Now, whenever we subtract logs, assuming they have the same base, we can use the quotient law, excuse me, which means that these two logs can be converted to a single log with the same base, where the arguments become a quotient. So it's going to become log with a base of 1 over 10 of 1000 over 1 over 10,000. Now, this quotient here, we in order to evaluate this, you're actually going to end up multiplying the 1000 times the 10,000. And the way that works is that if you have a double quotient like this, you can convert this to a product. So I'm going to do that on the side here. So this numerator here, 1000, is simply 1000 over 1. This denominator, this quotient in the denominator, will then be multiplied. So we multiplied by the denominator, the reciprocal of the denominator. So we're going to flip it upside down. So 10,000 over 1. So if we do this product, we're going to get 10 million. Now, we don't want to write all those zeros, so we're going to write this in scientific notation, which is the same thing as 10 to the power of 7. So we can shorten this a little bit now. We can now say that this equals to log with a base of 1 over 10 of 10 to the power of 7. So now we can go ahead and try and evaluate this. So we're going to equal this log to x. We're going to convert it to exponential form. So it's going to be 1 over 10 to the power of x equals 10 to the power of 7. On the left-hand side, we can use the negative exponent law. So we're going to move the denominator across the division line upstairs. And at the same time, the exponent, which is x, is going to become negative. So it's going to become 10 to the power of negative x equals 10 to the power of 7. Once the bases are the same, we can drop the bases, which leaves us with negative x equals 7. Multiply both sides by negative 1 to get rid of negative x, and we get x equals to negative 7.